Okay, the idea of finding the greatest term is a little bit different, but pretty close to what we've done before, what we did before with the greatest coefficient. So the greatest term basically means is we're going to do a substitution of an x value in, and then see what value of r must give it for. But now this can really change depending on what value we put of x in, because the value of x will always start to change the actual values that we get for the greatest term. So it always depends on what value we put in there. So again, the process would be, if we find our greatest coefficient, and notice before when we had the x in there, and we can have a look, we took out the x here, but if we leave it in there for those, the powers of 4 would be the same as the power of x. So instead of having 4 there, we'd have a 4x and a 4x, and that would be a 4x there. So that's where the 4x stays the same. It's just, instead of having the 3 that the 4 in front that we had before, we've got an x that will be hanging around with it as well right the way through. So when we put x is equal to half, the x goes because we're going to actually put a value in, and we just get one expression in terms of r. But notice, because the half will have an effect on it. If that was a quarter, it would have a different effect. We'd get a different expression in this part. So if it was 2, it would have a different expression in this part as well. So it just depends on what our expression is there. But again, if it's going to have to be the greatest term, we're comparing our terms and saying, well, where is it going to be greater? For what value of r is this expression going to be greater than 1? So we set it greater than 1 again. So put the expression in, we get 3 multiplied by 3r. And this time when we do we see that we get a value of r that's less than 6 2/5. So what does that mean for us? Well, it means that our value of r must be 6. And if r is equal to 6, it means we're looking at the 7th term, because we'll have 15c6. So the 7th term is 15c6. 3 to the power of 9. Now 4 times the half. So x is equal to a half, and still in this case, to the power of 6. Still going to give us a large number, even though we're putting a half in there. So it's 6,304,858,560. That would be our greatest term when x is equal to a half in that expansion. So again, it may be different if x was equal to 2, or if x was equal to the third, or x was equal to a fifth. It could be different terms that would give us the greatest coefficient. But in this case, we've got r is equal to 6, and so that gives us our greatest term. So same process, just a little bit different. We're keeping the x in, and we're going to do a substitution, but this process would stay the same.